Okay, let's look at the last of our new function. They're our trig functions, all right? So, again, these are the ones that I'll highlight in red that are on your formula sheet, all right? Okay, but it's almost these ones here in bold that are the most useful, all right? So, key things to remember here, and you've got a formula sheet, so that helps you to remind you. The derivative of sine gives positive cos, but the derivative of cos turns into negative sine. All right, so there's my positive cos becomes negative sine. Sine is just cos. All right, tan, it becomes sec squared. Now we may not have seen that function much before, and we don't really deal with it. I guess just to help clarify, 1 over cos x is the same as sec x. All right, now we don't do a lot with the sec function. All you need to know is if you want to evaluate what sec x is, we have to work with this form here. So for example, sec of pi on 3 is equal to 1 over cos pi on 3, which is 1 over, what's cos of pi on 3? A half, which is equal to 2. All right. So we in terms of manipulation of the sec function, we do very little. You just got to realize that the derivative of tan is sec squared. All right. Now, and again, it's that same principle. If I've got the sine function, sine of a function, it's the derivative of the function at the front, and we turn it into cos of the function follows. If I've got cos of g of x, it's the derivative of g dash of x out the front, or the derivative of g of x out the front, and we swap it into a sine x function with a negative. All right, tan of a function, derivative of the function at the front, and it becomes sec squared of the function. So with all of those, we haven't changed the function at all, have we? Okay, so let's just do these few little bad boys. Scroll it down so we can see the formulas. There we go. So first things first, if y is equal to cos 2x, dy dx is equal to derivative of the function inside, derivative of 2x is 2. Now cos becomes negative sine, so I'm going to write negative sine 2x. All right, so up here, the cos becomes negative. All right, what about the next one here? F dash of x is equal to derivative of the function inside, which is 2x minus 2, times, well, sine becomes cos, and it's just x squared minus 2x. All right, so the sine function becomes cos, positive cos. So it might be just a case initially of having your rules there and going, okay, I know sine becomes cos and cos becomes sine. I just can't remember about the sine. All right, so maybe the little formula helps you to remember about the sine. What about tan? So g dash of x will equal, so the derivative of the 2x minus 1 is 2 times, we've got the 2 there, derivative of tan is sec squared x, and 2x minus 1. So that's just equal to 4 sec squared 2x minus 1. Okay? If we've got a combination of functions, same process, dy dx is equal to derivative of 2x minus 1 is 2. So I go 2 times 2, derivative of sine is cos, and the 2x minus 1 doesn't change. I've got cos a half x there, so the derivative of a half x is a half. So I've got minus a half, derivative of cos is negative sine, so that negative at the front has to turn into a positive, and the function doesn't change. All right, so let's simplify. 2 2s are 4, 4 cos 2x minus 1 plus a half sine x on 2 or a half x. All right. So it's at this point in time, this is really what this chapter is about. It's learning a couple of rules and just learning a few new functions. All right. And then we're going to use these derivatives to help us find maximum points, tangent lines, minimums, points of inflection, stationary points, etc. All right, off we go.